Thank you for reaching out, and I guess welcome to a very impromptu curtain wall conversations episode. I'll set the stage for our viewers that you guys reached out because you read our blog posts, seen some of our podcast episodes, were curious about fiberglass frame curtain wall, and that was kind of I thought as good of a pretext for an episode and a conversation. I'd love to hear a little bit about each of your backgrounds and how you kind of found out about us, and sort of what makes you curious about curtain wall in general and fiberglass in particular.
My name is Fadi, and I have a diverse experience working across various industries, including construction, automotive, and energy-related product development. My background spans in engineering, project management, and strategy. Currently, I'm working as a project manager at an energy product-related company in the US, and I worked for over 8 years in the construction industry in the Middle East, delivering some projects in Dubai, Abu Dhabi, and Qatar. And I have like good connections and network there, and that's what started the whole conversation. Like we were trying to find some innovative products in the industry. And I have a friend, his name is Akshay, and Ashwin is a common friend between us, and that's where everything started. So we were discussing the fiberglass industry and how can we implement this in the Indian and the Middle Eastern market where construction is currently booming, right? And that's why we came across your company. We were in our research, we were researching fiberglass companies or companies that deliver fiberglass solutions. And there are very, very few of them, and yours came right away, right? And then we started listening to your podcast, and we became even more and more interested to explore this. And that's why we started like studying the market and doing some research, but we were faced with a lot of obstacles. And that's why we're excited today to discuss the fiberglass implementation, as well as evaluating its current feasibility in the market and the challenges it faces.
I'm Ashwin, a pre-final year mechanical engineering student in India. So I've tried to build a foundation in various fields, including design, analysis, vehicle dynamics, and robotics. I worked closely with Akshay on this project. So my role was to see the technical feasibility of the project and bringing it here to India. Yeah. And I'm glad to be on this podcast. Thanks.
Maybe your first question might be why curtain wall? Of all of you guys obviously have a broad variety of interest: automotive, robotics, energy more broadly. I obviously have an interest in a lot of those as well, but sort of professionally focusing on in curtain wall. What is it about the curtain wall market that whether in North America or in India, where I understand you guys are both from or based, that you guys see so much opportunity in particular in this industry or in that subset?
For me personally, it's because I worked in the construction industry for a long time, and I see how innovative products gets to the market quick, especially in the construction. If it's a successful idea, it would spread, right? And right now, so Ashwin is from India. I'm originally from the Middle East, but living currently in the US, and having worked in the Middle East in the construction industry. And I'll tell you how this whole thing started, right? So me and Akshay, who was the common friend between me and Ashwin, we were sitting in an office, right? And it was freezing, it was like a curtain wall, and it was freezing. And here in Michigan, freezing relatively, of course, to you in Canada, right? But it was really cold, right? So we were thinking what, with the heater on and all, it's what's going on? And then that's what sparked the idea. And then we started looking into it, and we saw that it's because of the aluminum. There's a lot of transfer of energy, right? And that's why we started seeking different, what could improve this. And then we found out that fiberglass would be a great solution for that. And so it all started with this basic, simple incident, and then we started digging into it, and we were looking for a lot of business ideas that we can implement. And that's why we started exploring this more and more, and here we are.
And how long ago was that you were sitting in? Was it a restaurant? Was it a library?
It was like, yeah, a library, like in an office, like office in a library, yeah. So
Right.
this was like a few months ago, like back in December, end of December.
Having worked across the world in construction, you've certainly probably never had that kind of situation in Dubai, in the Middle East, in the Emirates, where you're sitting next to a curtain wall and it's, way too cold, for example. I mean, not having a ton of experience in super hot climate, I know obviously it can get to be 50 plus degrees, above zero there. What are the curtain wall concerns? And this just for my own general, curiosity. What are the curtain wall concerns in those super hot extreme climates?
I can't think of concerns. Like currently, the market is more lean to like use aluminum in most of the curtain wall stuff, but
Mm-hmm.
also like I feel the market is very acceptable of new
Mm-hmm.
ideas, right? And that's why and like there's a lot of spending on electricity there, like on cooling, right? HVAC and stuff. So this would be a big factor on saving and reducing the HVAC system for these new buildings and skyscrapers that are getting built right now in
Mm-hmm.
that market, right? Which will do saving. But again, like in our, I would say preliminary studies, like we met a lot of obstacles where we see that it's not very feasible, and that's why we start reaching out to people like you,
Yeah.
to see, like, to convince us to get back to this. And
And yeah, I mean, so then maybe that's a good jumping off point for us to sort of describe how we see fiberglass kind of currently in the industry, and why it works so well for us, and for the sort of northeastern United States market and the sort of Canadian market more broadly. And that really comes down to your experience of how cold it is, right? And that you know if the sort of comfortable sort of room temperature is say 20 degrees Celsius, round numbers. Maybe it's 22, maybe it's 19, call it 20 degrees Celsius. If 20 degrees Celsius is the sort of comfortable temperature, well, then in let's say, India or the Middle East, for example, and if you get a, plus 50 is probably the most extreme kind of temperature you would see, Celsius, that's a 30-degree difference between interior and exterior environments. So that's the kind of amount of thermal bridging that you're having to compensate for, is 30-degree delta between interior and exterior environments. That's at the very, very extreme. In the colder parts of Canada where we're dealing with, we have to deal with maybe 70 degrees, right? Minus 40 and minus 50 even. We do work up in the territories, minus 50 and then 20 degrees Celsius. So 70-degree difference between the interior and exterior environment. That's a dramatically more extreme stress on the building envelope, and that is creates a lot more thermal bridging to minimize. Right there's that much more thermal bridging to reduce, and the benefits to reducing that thermal bridging are that much more pronounced. And so between the sort of amount of the sort of extremeness of the climate on the cold side relative to what's a sort of comfortable ambient interior temperature, there's just much more stress on the building envelope from a thermal perspective. And this is really where fiberglass really excels, is thermal. Fiberglass has a lot of other limitations, right? It is certainly more expensive, as a capital expenditure upfront than aluminum is. It's a little bit heavier actually than aluminum. The kind of shapes that you can make with it, the designs, the sort of different profile dimensions, as you can kind of see here, it really likes to be this very rectangular, very boxy shape. It's difficult to do custom shapes. Custom pultrusion dies are very expensive. They're about an order of magnitude, so about 10 times more expensive than aluminum customized dies. So if you have a bespoke project with, certain kind of corner conditions, certain kind of, radiuses, certain kind of bending, fiberglass doesn't really want to do any of those things particularly. It flat out can't do some of those things, and the other ones are often cost prohibitive. When it comes to more expressive geometry, if you want to do a Bjarke Ingels, a Zaha Hadid, kind of structure, I mean, you almost couldn't achieve that with any other material other than aluminum, right? And there's actually a variety of other materials that are used in curtain wall, right? Steel is used in curtain wall. Bronze, is used in curtain wall. We talked about this with, Mies, Seagram building, right? Seagram building has bronze frames. Wood frames, are used for curtain wall. Again, for very niche applications, but they are used. Of course, aluminum is the sort of most commonly used, but it's far from the only material used for framing of curtain walls. But aluminum is used because it's the least expensive and the most flexible material, and also the most flexible material across climate zones, right? So, frankly, in a more temperate or even hotter climate, the windows and doors are just open all the time, right? I mean, you go down to Phoenix or something like that. You go to Arizona and you go to the Taliesin West, Frank Lloyd Wright's, and everything's single glazing, but just the windows and doors just open all the time. For 3/4 of the year. There's probably a few days when it's too hot and you have a little bit of air conditioning, or it's too cold and you sort of light the fireplace or start the furnace. But for the most part, the difference, the delta, again, between the interior and exterior environments is actually so mild, right? For so much of the world, really. And so fiberglass really is designed, and what we really saw, and this is why, we started in 2010, doing our R&D, or 2008 even doing R&D, but 2010 commercializing, is that the pain point was really in cold climates. And that's exactly what you noticed, Fadi, with, when you're in Michigan, right next to the curtain wall, and it's -20 outside, Celsius, around 0 Fahrenheit, and you're like, this is miserable. Like, what the hell is going on here? Like, this is insane. And that's when fiberglass and triple glazing, particularly as well, really make a lot of sense, because you can reduce the heating and ventilation. You can actually even almost eliminate the perimeter heating with a high performance facade. You can open up the space. You can functionally expand the sort of usable area. You can have people be right up against the windows of the curtain wall very comfortably, leaning up against it even. Construction is geographic, right? Construction, and it's not to say that there won't be, advantages to fiberglass in other markets. I mean, we see fiberglass being specified. We've done industrial projects where corrosion was an issue. And I think this might be actually interesting for the Middle Eastern market. I don't know about India as much, but when you have a very humid coastal environment with a lot of salt in the air, and a lot of salt in wind-driven rain that's very saline, you can have corrosion issues. And actually, some of the first fiberglass curtain walls were in Saudi Arabia. Oh, wow. Actually, so there actually are some predecessors to what we're doing. There's like one, I've never been, but there's like a 20-story building that has stick-built fiberglass framed curtain wall. And I would actually have to do some research, and I'm sure I can get a picture. Hopefully I can get a picture up on the screen to find and dig out of our archives. But about 10 years, so early sort of boom in that area, sort of, early 2000s, kind of the big construction boom, late 90s, early 2000s, there was a fiberglass room. I think it was double glazed. It didn't have the kind of, air tightness and sort of membrane integration that we would, use in a colder climate here. But it was mostly, to my understanding at least, used because of how sort of corrosive the environment was, and the sort of the corrosion resistant properties of fiberglass that were attractive. And as far as I know, that building's still standing and still performing well. But it, I think that it didn't have it didn't have someone to really market it, right? Because it's one thing to have a great product, but if a great product is sitting on a shelf,
there's no good marketing, then it won't succeed. Yeah, that's for sure.
That's it. And so much of construction is relationships, and so much of these relationships, and I think you'll have, if you guys do go down this path, and you do pursue this, I think you will benefit from the relationships you already have, from being in the construction industry. But what we found is that the relationships that were most important were really the relationships with architects, who are specifying this. Developers are one kind of relationship, building envelope consultants are another kind of relationship, general contractors another kind, glazing subtrade another kind of relationship. These are all possible relationships you might have. Clients, you could have the client being this municipality, this pension fund, whatever it is. But we found that, through trial and error, through a decade plus of trial and error, finding out who's really, pulling the levers and pushing the buttons in the control center, to sort of determine what is being specified for high performance, very specialized systems, are the architects. And that's what we found, is probably 80% of the sort of traction that we're able to get, and 80% of that decision-making capacity is coming from the architect. And then, of course, there's other stakeholders as well, and we have to, make sure that general contractors are happy, and the glazing subtrade is happy, and ultimately the client, of course, is happy. But the architect is, I would say, the majority.
One of the questions that I had prepared. Yeah. So you think then engaging with consultancy firms like architect consultancy to include in their project specification is vital, right?
Absolutely. I mean, for such a specialized niche product, there's so many products in the world, right? There's thousands of products out there, and most architects specialize, right, in a certain kind of building, certain type. Right? Some will do multifamily residential, some will do, government buildings, some will do, fire halls, some will do hospitals, whatever it is. They tend to specialize. Some will do single family homes. And there's so many products in the world that from project to project, they're probably reusing 90+% of the spec from the last project.
Even in my experience, with construction, it's usually copy paste, right? Like the same spec is copied from a project to another.
It has to be. And I don't say that, as a negative. I say that observationally and just objectively. Right. It's because there's just too many decisions to make and not enough time and not enough budget. If you had to do 100% new construction, 100% new specification with 100% of the things you've never done before, it would take you 20 years to do one project, right? Correct. But you only have a year or two, a year to design, maybe. And so you only have so much time, and you maybe have, 10% of the project, and I'm being, I think, generous, probably 10% of the project, where you can make some improvements or try some things or use a system that you've always wanted to use but didn't have the right opportunity to use. This is what we face all the time, or what we see all the time. Architects, there's probably 5 or 10 architects that want to specify our products for every one that gets to specify.
I see.
Our products.
And that's get us to my next question. So based on your experience, then how do you first approach these architects? What's the best way to approach them? And are they are they accepted? Did you sense their acceptance to change, or is it the industry is currently aluminum, the specs are aluminum, so we're not gonna change this? How did you manage that?
Yeah, again, through a lot of trial and error, through talking to a lot of different kinds of firms, and we've over the years been able to find the kind of values aligned firms. Right? There's many kinds of architecture firms as well. Not only, and even within a category of, these are all the ones that do healthcare, hospitals, for example. Within that category, there's, the kind of average, there's the slightly above average, and there's the great ones, right? There's, broadly speaking, there's a few different kind of categories of architecture firms. Some will be more focused on cost effectiveness. They want, they'll give you the cheapest hospital you can possibly have. Some will be more for sustainability. They'll give you the greenest, lowest carbon hospital you can have. Some will be the most architectural, the most avant-garde, hospital you can have. I think of those ones, we found the best alignment, somewhere between those latter two categories of, the most sustainable and the most architectural. We don't tend to do a ton of work with the ones who are just looking for the cheapest, fastest, lowest cost, lowest quality thing you can call a building. Those ones those ones we also tend to see are also mostly working for developers, right? With all due respect for developers, incredible entrepreneurs that they have a different incentive alignment that is definitely away from higher quality, innovative, more sustainable products. In our experience, at least in the North American market. I don't know. I won't pretend to speak for every market in the world, and all of the incentives and all the different kinds of business models that developers have. But the America tend to build something sort of to code minimum and then chop it up and sell it. And they either sell it as a condo building or they sell it at the whole thing as in a rental unit to a pension fund or something like that. A couple years later. But they might make it, LEED certified, or they might, do something kind of, a little bit better on the surface. But typically they're still so driven by margins, that they're honestly going to have everything made in China if they can. They don't, at least in the North American market, they're not super fussed if something is high quality, Canadian or North American made, low carbon, et cetera, et cetera. They're not as interested in that. If they can get their stamp on it, they will absolutely just use something from overseas. And even if the quality doesn't work out in 5 years and the warranty is no good, it's not their problem anymore.
Yeah.
Right. It's the next person's problem. So unfortunately, that's the incentive alignment. So we focus on owner occupants. People who are going to own their asset, for the next 50 and 100 years. It's going to be, municipalities, different levels of government, universities, schools, First Nations, Indigenous, clients that we work a lot with, owner occupied, commercial buildings like Enbridge, that are basically crown corporations that, are, been around forever and will be around forever. Those are the kinds of businesses and organizations that, can see the value in what we're doing. And that we work best with. So, but that took a while to figure out, right? To figure out, of all of the world's, possible clients, of all the world's possible building types, for us, it's been low-rise institutional, right? That's been the focus. And that's where we see the best traction, the best engagement, the best value proposition that we can offer. It's not in high-rise apartments. Yep. It's not in single-family homes typically either. So it's about finding your spot in the market.
Is that only because of the incentive, like most of developers are more incentive based rather than quality based, or is there like any technical drawbacks to using fiberglass in high rise? Or
I would say one of the technical limitations that we have currently when we have prototypes to overcome this even is the type of construction, and that's stick built versus unitized, right? So our thermoframe family of systems are stick built, which say they're site glazed, which is fine for, buildings up to 6, 8, 10 stories for the most part. For the most part these days, Seagram building back in the 1950s, all 40-story building, stick built, right? Site glazed curtain wall. That was done at a time. Today, no one seriously in the world is doing anything taller, anything approaching that height of 20, 30, 40, 50, 60 stories. It's unitized curtain wall for sure. And we have, again, some prototypes for that kind of system, but that's also a different kind of business we found out as well. A unitized business is actually requires a very different kind of facility even, right? I mean, that size of facility to make that many prefabricated panels, there's a lot of scheduling risk as well in those kinds of projects. They can be big, it's also much more global. They can be big reward, but they are big risk. They're big risk projects. And, to be fair, I mean, it took aluminum curtain walls took 30 years before they had unitized systems. And we've been around 10, 15 years, call it. And so, in the fullness of time, in another 10, 15 years, could we be doing unitized systems as well? For sure. I think this is certainly a possibility if we see the market demand. We also see that the higher performance buildings also tend to be low rise, right? The ones that are going for net zero, the ones that are going for passive house, and the ones that can't sort of fudge the building envelope, values, they don't have as many chips to play with, are the low rise buildings where they have a relatively smaller envelope to deal with. And if you want to achieve 30%, 40%, 50%, window to wall ratio in these, smaller building forms and typologies, you don't have as many chips to play with. You can't sort of cheat it we'll have a little bit, this part of the building will be, like the Winthrop Center in Boston. Maybe you've seen that one. It's a passive house building, but it's like this part of it's passive house and this part isn't, right? And so they kind of have these like, this part's all curtain wall and this part isn't. And so they kind of have a little more chip to play with because it's such a big building and there's so much volume to play with that they can have it still be in a colder climate and still be an aluminum frame curtain wall to passive house standards. With a smaller building, you don't have those degrees of freedom. The envelope has to perform. You can't fudge it. And so that's where we've seen the real need, the real demand for a fiberglass high performance system is in these sort of low rise, passive house LEED certified, net zero buildings. And that's been through trial and error. But that's what we've found.
Okay. So then it's basically like the demand, right? It's not any technical challenge or drawback for high rise, but because I think most of the new buildings that are being constructed in the Middle East nowadays are high rise. Like that's the more focus, especially in developing markets like Saudi now. And I would say United Arab Emirates are kind of like developed in terms of the construction boom, but Saudi is still now on the rise, right? But most of the buildings are high-rise buildings. But you don't see any technical challenge in this for fiberglass. Nothing.
Not particularly, no. I mean, again, there'll be some constraints when it comes to geometry, because again, fiberglass custom protrusions are quite a bit more expensive. But again, on a larger building, maybe that's not even a huge deal. I mean, the scope, on a big building, you're talking about what, 10, 20, $30 million of curtain wall or something like that, right? So what if you have $200,000 of die designs? It's all good, right? That's like a fraction of a percent. Even if you had even 1%, it's still, $300,000. So, I think it's probably a rounding error in that kind of scale. So you might even be able to overcome geometry limitations by just having, good custom protrusions, and, finding good designers. Protrusions are, they're complicated, right? And aluminum alloys that are used for curtain wall are composed of, 2 or 3, materials. But a fiberglass composite is composed of dozens. And the physics and the math of calculating and modeling what are the interactions and what are the different kind of layers to the fiberglass and the interactions of the different kind of directions and types of fibers and composite materials and resins all interacting with each other. We've found great success with a couple of different innovation centers that are available here in Canada to help us with some of that modeling, because it's very complicated, and it's not as simple as we'll just extrude it out of aluminum and it'll work, right? You do have to do a lot more designing, a lot more testing, a lot more stress testing and analysis before you have the confidence to put it into production. Again, if you have good designers, good protrusion partners, then I think there are certainly architects who are interested in trying high performance systems, and we'll see opportunities in differentiating themselves in the marketplace as well, and doing something that's more sustainable, that no one else is doing, that's ahead of the curve, that's avant-garde, that is, that's a selling point for sure for them as well.
So since we're talking about the technical feasibility, right? So we did some calculations using tools like Window and Thumb from Berkeley Lab. Then we performed CAD modeling. We sent the drawings to the manufacturer. We did structural and thermal simulations. Um, but is this the right approach for from a business standpoint, since we're entering a different material or looking into a different material?
I think you have to. I think you have to try. I think you have to try and see. And I think the first project's the toughest, right? Getting in the ground. You'll learn a lot by doing, and a lot of it is only learned by getting your hands dirty. There's a certain amount that you can model. There's a certain amount that you can predict. And then you're going to get into the field and find properties of fiberglass that you didn't know existed. And some of them will be easy to overcome, and some of them will take some engineering. We'll take some thinking, and we'll take some problem solving. And the only way to figure these things out is to do it.
Yeah. So basically, prototyping would be the way to go with.
Absolutely. Prototyping is the way to go. And then find a way, find a client, find a friend, find a contact, find an architect, find a glazing subtrade, find a team to help you actually put that prototype into the real world. And even if it's small, even if it's just a few hundred square feet, if it's one facade, right? One frame, but get it into the real world, install it, and see how it performs, and learn from that, and grow from that, and incorporate those lessons learned into your next project, and your next project, and your next project. But that it takes time. This is an industry that rewards patience. Thankfully, you guys are young. This is there's some time. But this industry certainly rewards patience, and it should, right? I mean, the products that we're selling, as it were, are expected to last 50 to 100 years plus.
Yeah.
Right. And if you're just selling, some kid's plastic toy, even if you're selling, a tennis, whatever, so sports equipment, even something as complicated as a cell phone, they're not expected to last that long. So people are more eager or more open to trying new things more quickly, right? They'll try something, because if it doesn't work, a year or two down the road, you just get a new one. A couple of years down the road, that's fine. But when something has to last 50 and 100 years or more, yeah, there has to be a little more risk aversion from the architect side. So, an architect, a contractor is going to want to see that this actually exists, that you can touch it and feel it and see it, even if it's, even if it's far away from where they happen to be, from where they are and their products are. They need to know that it exists and that it's performing the way you expect it to. And if it's not performing the way you expect it to, then you did it again, and then it is performing the way you expected it to. And so, yeah, it will take some prototyping. It'll take some beta testing as well, some in situ beta testing, to figure this out on your own dime effectively, right? If you can find a patron, that's all the better. But you need to be making that investment. Your team needs to be making that investment to prove to yourselves before you can convince someone else, right? You need to have more confidence even than just, oh well, we drew a really nice thing on a page.
Yep.
Right.
Yeah.
No one's gonna give you $1 million a contract because you drew a really nice thing on a page. It has to be able to touch it and feel it and see it, and know that, and have confidence that it's worked, over a couple seasons already, probably, before they will give it a serious consideration.
We have another question. So throughout our research, right? So we noticed or we observed that energy savings with fiberglass take a long time to break even, especially in the Middle East and your Indian region, right? Especially with the relatively lower prices of aluminum. So like, why would developers and decision makers choose fiberglass if we want to convince them to choose this?
Mhm.
I know you
Yeah,
mentioned earlier that this probably fiberglass is more more relative to the colder climate. Is that right? Like especially with the temperature difference between indoor and outdoor. So
absolutely. And that sort of payback period, as it were, is much quicker in a colder climate
colder.
where we have that bigger delta, that bigger difference between interior and exterior temperatures on average, especially in the extreme. Um, and so, the other part of the sort of payback period is again, who's the client, right? If the client is a developer, the developer's idea of a typical developer, again, maybe it's different in the Middle East, you can tell me. In North America, the typical developer's, idea of ROI is like 6 months, not 6 years, not 16 years, not 60 years, 6 months, right? And so that's a big limit. That's a big limiting factor for the kinds of products they're going to choose, and the quality of the products they're going to choose is going to be something that lasts 6 months, give or take. And if it falls apart after that, that's someone else's problem, right? They set up, anyways. That's
Yeah.
kind of their incentive. So trying to persuade a developer, I think, is, at least for a premium product, in our experience, you'd be barking up the wrong tree.
Yeah.
For a premium product, for high performance product, it has to be conversation about not just energy, but also durability, right? Whether it's durability to corrosion, whether it's durability to expansion and contraction and the stress on the gaskets and the seals and the edge spacers of the IGU. If you can reduce the life cycle impact, the wear and tear on a building envelope, you can reduce the wear and tear on a building envelope, and you can extend the lifespan of that building envelope by whatever, a certain amount. That's a very compelling proposition for an owner-occupied client, right?
How's that compared with aluminum? Like, is fiberglass lifespan is much longer than aluminum, you think? Or
So fiberglass expands and contracts a lot less. Fundamentally, there's a material science
yeah.
property of fiberglass. It expands at about half of the rate of aluminum, and so it actually expands at effectively the same rate as the glass that it's holding in place. Whereas aluminum is actually expanding and contracting at twice the rate. So they're expanding and contracting in different directions. So to the extent that your clients or the clients of the architects that you're speaking to have concerns with air infiltration and exfiltration, leaky building envelopes, and they have experience with leaky building envelopes, the more that you can identify that they have a pain point, the more you can say, oh, great, we have this very thermally stable system, this very thermally stable solution for you. I know aluminum is not great for, leaky building envelopes, and, you're having problems with this. Fiberglass is great for that. Fiberglass is definitely more durable when it comes to the gaskets that it's holding in place from an expansion contraction perspective. And that means that over time, you have less heating and stress on mechanical systems as well, right? Investing in a passive aspect of a building envelope will always reduce strain on the active aspects of the building, right? So those heating and ventilation systems that, yes, aluminum is maybe cost effective up front, but what's the cost of prematurely replacing heating and ventilation equipment, right? Because it failed because the envelope didn't perform as it was supposed to. So that is a cost that, a more thoughtful owner-occupied client will look at. They will look at, okay, well, what can we expect our building envelope to do in scenario A, in scenario B? Again, every building type is different. We're not going to make super broad sweeping generalizations to say, oh, it's this much percent, this many years, that many years. Every building is different. We would love to be able to generalize, but this is why modular construction of buildings is so hard because it's very, very hard to generalize. Every building, every site is different. Every climate is different. Every geography is different. Codes are different everywhere. And then, every environment is different, and every temperature is different as well. But what we know are the physics. The physics don't change. Yeah. Everywhere in the world, the physics are the same. And we can say that fiberglass expands and contracts at half the rate of aluminum, and is very corrosion resistant. And these are and very resistant to thermal bridging. These are physics things that are true everywhere.
So you mentioned codes, and that brings us to one of our questions as well. So, like, what do you think, like, what role do regulations and building codes play in either supporting or hindering fiberglass adoption? And what's your experience in that?
So codes do both. Codes help and hurt.
Okay.
Helping side are the U value side, thermal performance, U values, R values, thermal performance side. So like Massachusetts stretch code, for example, just implemented recently. BC Energy Step Code, similar, in British Columbia, Vancouver. Those are great for what we do. Those massively encourage innovative, higher performance facades in order to maintain the window to wall ratios that clients are expecting and the beauty and the daylight that occupants kind of demand. That's great for us. On the hindrance side are things like fire codes. And we've done whole episodes on this in the past. We'll link to those if you guys haven't checked those out. We definitely recommend them. And this is very geographically specific as well. I mean, thermal, energy, building envelope energy codes are very, geographically specific. Massachusetts leading the way in North America, even ahead of things like Toronto Green Standard or what have you, or BC Energy Step Code. But the fire codes, Canada has one, the US has a different one, Switzerland has a different one, Germany has a different one, Saudi has a different one, India has a different one, to the extent that they may recognize potentially, so one or the other. I mean, in Canada and US recognize the same ASTM standards for air and water penetration, ASTM E283 and 331. But they don't recognize the exact same fire code yet. That can change. Yeah. We don't know. We're going to see. The tests are very similar. The only difference is the US test is a 2-story assembly and the Canadian test is a 3-story assembly. But broadly speaking, they do the same thing. So we'll see what happens with the codes. But the fire codes are one area where, at least in North America, currently, for many applications, fiberglass is treated differently than aluminum, even though they perform the same in a fire. And we've demonstrated this on 3 tests now with Intertech in Texas. We've done 3 tests where we've demonstrated equivalency between aluminum and fiberglass. They'll perform effectively the same.
I saw that on one of your videos. Yeah.
Yeah. And so the codes are starting to actually accept this as well in Canada, and I'm sure the US will follow suit in good time as well. But the regulatory landscape is always changing. And if, I think at this point, from a pure physics perspective, again, from a pure technical perspective, you would look at, okay, these curtain walls are 90% glass. Whether you're framing them with aluminum or you're framing them with fiberglass, they're still 90% glass. No one's considering glass combustible. That little 10% of framing that you have, whether it's mostly aluminum or mostly fiberglass, there's still kind of a hybrid, right? I mean, there's lots of aluminum frame systems with fiberglass pressure plates. Our fiberglass systems have some aluminum components. Who's to say that it's going to make any difference at all? And we've tested the we have in situ, projects completed. We've done sort of laboratory testing to demonstrate equivalency that it doesn't make a difference from any practical perspective. The codes may may or may not agree with that very technical, physics perspective yet, but they're starting to. And we've already seen this in the Canadian fire codes, for example, that as of Building Code 2020, which is just being adopted by every single province now in 2025, there's a bit of a lag, that they're now recognizing equivalency for certain kinds of curtain wall applications, that fiberglass is the same as aluminum. And so you don't need this additional, for here, it's CAN-ULC S134. You don't need that testing for certain kinds of applications now. And another 5 years, it could be that you don't need it kind of for any applications, because we've demonstrated essentially equivalency, right? So unless you're going to make every aluminum system also go through this 6-figure test, then, fiberglass is good to go. And I think from a very pragmatic perspective, if you actually want to have higher thermal performance and lower carbon, well, then let's get out of our own way a little bit. If we're tripping, we're tying our shoelaces together and wondering why we can't win the race. It's like, well, how about we, don't tie them together. We just tie them separately and, just run. So this is, there's opportunities everywhere, and the regulations are slow to adapt. But I'm confident that we'll get there.
So, like, looking ahead, then, what do you think needs to happen for the fiberglass to gain mainstream attention and acceptance in the curtain wall industries, and why hasn't it gained that acceptance and adoption yet?
Great question. And I think that fiberglass we never brought fiberglass systems to market. We never brought the glass curtain systems to market to be, I guess, mass adopted. We never brought them to market to be, oh, we're going to be 90% of the market one day. We'd be happy, like Steve Jobs said, and when we came with the iPhone, we'd be happy with 1% of the market. The high performance end of the market. And because we are leaders and the market, we sort of, create, white space for the market to follow us, for the market to catch up to us. So the leader in the market, which is what we are, to a large degree in our niche, creates a wake. It's like you're in a boat. Or like an icebreaker, more like an icebreaker. Yeah, that's a better analogy. We're like the icebreaker. Very hard work, very difficult to do, much easier to follow behind, right? So being that first icebreaker, it's like if you wanted to, take over all of, go from A to B, you maybe just, you maybe go just take all the water around it, or you fly over it or something like this. But, to be the icebreaker, to really sort of show what's possible from a thermal performance perspective, it is a niche. It's inherently a niche. And we're okay with that, because that's still, a good business. That's still, intellectually stimulating. And that's still, we think, a valuable service to the community and to architecture and to construction. And, I think that's what's important to see, is that we are, fiberglass satisfies a specific need in the market. And we recognize that that's not every need in the market. In the same way that window wall is not every need in the market.
That's correct.
Window wall is a certain kind of need. It's like, how do we make it look like curtain wall, but unbelievably cheap, right? That's a need for a certain kind of client. That's what they think their need is. That's fine. That's what window wall exists, to make it unbelievably cheap and look like curtain wall. It's not true curtain wall, right? It's cheaper. A steel framed curtain wall satisfies a certain need in the market for ginormous spans, right? In giant lobbies and airports and hotels and things that aluminum can't do. It has to be so strong, way past what aluminum can do, even with reinforcement. So steel satisfies that niche. There's wood frame curtain walls for people who like to touch and feel the wood. Right? This is a need. People want to touch and feel wood. So so Ryco and whoever else, Unicel, have a wood frame curtain wall, and a few other guys. Right? This is satisfying a need. Fiberglass is like that as well. That it's a niche, and it's one that we feel was underserved until we came into the market, and we have every expectation that there will be, more market participants, and we've already seen, several of the sort of more, fiberglass window companies try to get into the commercial space. But, they've kind of been challenged to go from the residential to the commercial markets because they're actually quite different. Again, there's different logic to the market, different kinds of expectations between residential and commercial. And we've chosen to focus on commercial and not residential. And I think it's important to, again, find your niche, find where you excel, and not to say that, you stay in your lane or something like this, but that you can't do everything either. Yep. And you don't want to do everything. You want to be the best at, in the sort of areas where you think you have a competitive advantage that no one else, it's a blue ocean strategy, right? You sort of go where, go away from the sharks and the red, blooded in, bloody waters, right? And you go to the blue waters where there's opportunity. It doesn't mean it's easy. You still have to have the product. You still have to, convince people that you're worth it, especially when as a premium product. But that's still, I think that's the opportunity. I think the opportunity with fiberglass is that there aren't that many people doing it yet, and that it's easier to differentiate yourself with a different material. And it's not that you're going to be on every project any more than wood frame curtain wall is not going to be on every project. Yeah. It exists. It's great for what it is, but it's going to be for a certain kind of application. And in that application, it's going to be the best solution possible. And there's going to be nothing else that can do what it does for that application. And so we're sort of leading in fiberglass, and I think that's I think that's what adoption looks like to us is sort of satisfying those pain points for those clients that need something that's net zero, low carbon, highest thermal performance possible, made in North America, these kinds of things that they want to tick those boxes and satisfy those demands. That's what they need.
And that's why I think it makes sense for your company that is already like in the curtain wall industry, but and that's why sometimes we question ourselves in our very new journey for the last 3 months is why would we go into a business that has many obstacles and might not find acceptance or a wider market, right? Why not pick a business that has fewer obstacles, right? If you would convince us to come to this market, how would you do that?
Yeah. Great. No, I mean, obstacles are a moat, right? So when you talk about businesses, you talk about what's your competitive moat around your castle, right? You have a castle with a moat with alligators inside, right? Chomp, chomp, chomp. Yeah. A drawbridge coming down. Yeah. What is your moat? In order for a business to exist, it has to have one. So it can be, you're the only one in your geography doing X, or you are, the cheapest. That's a kind of moat until it isn't. You can be the highest performance. And you guys are in automotive. Look at the car market. What is Toyota's moat? What's Tesla's moat? What's Ferrari's moat?
Yep,
right?
Different. Yeah.
Each of them are doing something different. Each of them is trying to be the best in its area. And that could be on reliability, like Toyota, that's their moat. Most reliable car.
Yep.
You want one car, you got a Corolla. That's it. That's the answer. If you just need one car, the most reliable car in the world is just get a Toyota Corolla. Yep. You want 500,000 kilometers? I wouldn't pick or recommend anything else to anyone. Yep. In any climate, anywhere in the world, right? You could at -40, +40, Toyota Corolla. If you want, the lowest
car, yeah.
If you want the best tech, the best user interface for your interior, tech, Tesla has the best tech, right? You want the sort of easiest user interface, the most constantly updated features, Easter eggs, over-the-air updates, best software, best tech, Tesla. You want the best, most emotional engines, you want Ferrari. No one makes a more emotional engine than Ferrari. Maybe Porsche comes close, but Ferrari right
It's
up there.
top of
Yeah.
its league. Yep.
And the most elegant designs and most classical, hardest to get. But their moats, each of them is very different from the other. And so, in the same way in curtain wall, the guy doing wood frame curtain wall, his moat is different than the guy doing steel curtain wall. It's different than the guy doing fiberglass curtain wall, or the guy doing window wall, or the guy doing passive aluminum curtain wall, or what have you, right? Each of these is a moat. So I would say that, why do fiberglass? I would say, and with all of the obstacles and how long it takes, and to get adoption, to sort of break into the market, I would say that's its own moat, effectively, because other people think it's too hard. If the easy stuff is the red ocean, right? The stuff with less obstacles, it's like, oh, I want to be an influencer. I want to be on YouTube. I want to be YouTube. I want to have 1 million subscribers on YouTube. Well, guess what? Get in line. 1 billion other people competing with you to do that. How many people are competing with you to do fiberglass curtain wall? Not so many. Not as many. Right? And this is like everything else. This is a fractal of everything else. The harder thing, it's like climbing Everest versus climbing the hill in your backyard. Climbing the hill in your backyard is easy. Yep. Right? Anyone can do it. Toddler can do it. Everest is hard, and this is why it's worth doing, because it's hard. And obstacles are competitive moat, and that's where the sort of success lies.
Like that. Yep. So you think then it has big rewards if?
Yeah, I mean, depends how you define rewards. I mean, if it's just financial rewards, there's probably other businesses if you're just looking for financial rewards. It takes a long time, and the capital investment is very high. You can be profitable, but it's not a get-rich-quick scheme by any stretch. The rewards for us, and this is someone whose family, I come from a long line of people who are in architects and curtain wall and building materials, and so for us the reward is that we enjoy this kind of work, and we enjoy traveling and telling our stories, and building cool buildings with great people and working with great people. This is a satisfying life, and that's kind of the reward, as much as anything, is that you get to leave your fingerprints, all over the world, and that's going to outlast us, right? Outlast 50, 100 years, right? These buildings will still be there. You show your children, show your grandchildren. Oh, that's the one that dad did. That's the one that great granddad did, right? And that's that's a reward that, I don't know, what's that worth, right? What's that worth? You can be worth, $1 million, $1 billion, and not have any legacy that lasts 50 or 100 years, unfortunately. So that's the kind of, I think, special part about construction in general, and architecture, and manufacturing in particular, is that you get to actually make things, right? Yep. Not many people get to say this anymore, right? Exactly, most people are just doing office jobs and spreadsheets and whatever. We get to make things, and we get to make them better and better and better, and constantly improve, and read the market, and find out what it needs, and constantly adapt. And it's that is very rewarding, and that's I could never put a dollar figure on how rewarding that is.
I love that. Yep. That was very insightful and very informative for us, and I gained a lot, like me personally. I covered most of my questions. I don't know, Ashwin, do you have other questions?
Yeah, I had one question. So it's about scalability, right? Can FRP manufacturing become competitive with UPVC or aluminum? And does it inherently have a higher cost? And if yes, what are the breakthroughs which you could make in the design to bring the costs down for the manufacturing?
Yeah, compared to UPVC, I think UPVC doesn't really exist in the commercial market here in North America as a curtain wall system. I've seen a few of the sort of passive house European kind of hybrid UPVC slash aluminum windows and things like that. I don't know how those would really deal with an extreme climate. I mean, UPVC expands and contracts like crazy.
Yeah.
It has very poor thermal properties. I mean, it has good U value properties, but very poor expansion and contraction. It's very thermally unstable. Has a lot of thermal instability, and so it's not appropriate for the kinds of projects that we're working on. We don't really compete with it. Could fiberglass ever be competitive with aluminum? Aluminum is inherently not very expensive, but it's also very political as a material, right? And so what we're seeing right now are things like tariffs. Yeah. Big tariffs on aluminum. Aluminum is also extremely energy intensive. And if energy prices keep going up, and there keeps being a very competitive, market force for energy from things like data centers, from things like AI, if the competitive landscape for energy means that energy becomes more dear, becomes more competitive, aluminum prices will go up, along with commodity price in general. And fiberglass prices will go up much less. The fiberglass prices are much less volatile to begin with anyways. Pricing is very stable. It's higher than aluminum for sure, but the pricing is very stable over time. Aluminum prices are very volatile, and with tariffs and with energy costs rising, it's possible that aluminum prices the aluminum prices could catch up in a way, or that gap could narrow. But the material costs aren't even the big part of it. It's actually the fabrication, like the actual labor intensiveness of dealing with fiberglass and the dust that it creates, the amount of specialized ventilation required to deal with that, special training, some special equipment that wears and tears faster because you need special diamond coated blades to deal with the cutting of it. It's very abrasive to cut. Those kinds of costs are just higher for fiberglass, and they will always be higher. Aluminum, even if the material input costs are the same, fiberglass will still end up being more expensive as a fabricated window system or curtain wall system. So I'm not sure that it's ever going to win on cost, but in the same way, is aluminum ever going to win on performance? Well, yeah. No, not from the physics say no, right? And so it depends what you're trying to optimize for, right? If it's just trying to optimize for cost, PVC is even cheaper than aluminum, right? Aluminum is even cheaper than fiberglass. But, sometimes sometimes you get what you pay for. In the same way that a Corolla is never going to compete with a Mercedes or something like this, right? They're different segments. It's like, well, is Mercedes ever going to get cheaper? Well, they have an A class, and a B class, and a C class, but the Toyota has Lexus, and it goes up, the same way too. So it's like, maybe they meet somewhere in the middle. There's some overlap, but at the extreme, okay, well, at the extreme, you have some Toyotas that are way cheaper and some Mercedes that are way more expensive, right? So there might be some overlap in some of the portfolio, but on average, there's still going to be a difference.
Well, thank you so much for your time, Peter, and thank you for giving us the opportunity to learn more about this field. And it's very insightful. Like me personally, I've learned a lot in this session, and thank you. We really appreciate it.
It's
thank
great.
you. It was a very informative session, and thanks.
And we wish you guys, the best of luck in whatever your pursuits may be, whether it is in the fiberglass space, whether it is in another space. You guys are obviously young, creative, full of potential, and it's a great sort of niche within the industry, within the curtain wall industry, and we'd love to follow your success and your journey wherever it takes you. So thanks to you guys as well for reaching out. as well on LinkedIn, and for finding us and for following all our episodes previously. And we look forward to keeping in touch.
Thank you so much. I will keep following your updates and news for sure on this exciting field. Thank you, Peter.